Hey, Stephen from TechMaker.tv here. In this episode, we are starting a new series. We're going to dive into how to build a blockchain from scratch, and we're going to do it with Ruby. I saw a guy do this in a talk I'm going to link to in the episode notes below the video recently. He went through pretty much a similar flow. It was how to build a blockchain. It's a great episode or a great video. I strongly encourage you to go watch it. We're going to go dramatically more in depth here. This is going to be between 8 to 15 or 16 hours of video, and you're not going to want to miss it if you're working in the blockchain space. This is going to show you the reason why we need pretty much every aspect of modern blockchains, and it's going to start off a little differently than what you would think. We're going to start by building out kind of a central system that you would think of for banking. Kind of lightweight, very, very lightweight, actually. And we're going to go from there. So to kick things off in this episode, we're going to jump straight into building out kind of a central banking apparatus for transactions between different customers of the bank. From there, we'll start analyzing it from different angles. How does that compare to what we do with blockchain and cryptocurrency? And we'll start sort of migrating away from the central system to what we now have as a blockchain. So with that, let's jump in. As you can see, I'm here in my terminal. I've created an empty directory called RubyChain. First thing you ought to do is just check your Ruby version to make sure you have something similar to 2.4. I think anything 2. Whatever is probably fine. If you do not have RSpec installed, you're going to want to install that, which you should be able to install with gem install RSpec. I've already got it, so I'm just going to, actually the first thing I want to do, because I'm going to push all these up to GitHub so that you can see where we start and end with each episode. So we're going to say make directory episode 1, and we'll just jump in there, and then I'm going to say RSpec --init. The next thing I'm going to do is open up this directory in my text editor, which I use Atom, which is a cool free text editor. Okay, get all this stuff closed down. Okay, so you can see that RSpec generated a spec directory with a spec helper. So when we write specs, we'll put them inside of this spec directory and we'll require the spec helper. Okay, I'm actually going to reorganize my windows a bit since we're going to do this writing tests. So let's move that there. Let's grab this guy, move it here. And hopefully that looks pretty good. Okay, so, and I've explained this in some other episodes, but if you see me doing a lot of shortcuts, like to close and open the file tree in Atom, you can hit Command \. So I'm going to create a new spec. You have to create a new file in the specs directory, and let's call it bank spec. And it's important that your spec, which is specification, and it's important to end in _spec to get run. So the first thing we're going to do is require spec helper, and we're going to start by just writing some code that's going to break. So we're going to require, actually I'm going to say require relative and say bank.rb. So now, let's clear that up. So if we run RSpec over here, we should get a failing example. I need to darken that up because that's a little bit hard to read. Give me a second. That looks a little bit better. It's kind of gloomy, but that's okay. Okay, so you can see here that the error is basically saying we can't load this file, so we need to make the file. We're going to put it inside of the episode 1 directory directly. So we're just going to make bank.rb. And close back the file tree. So these are the two files we're going to be working with for a little bit. So if we run this again, we should be passing. And so in TDD. I don't know if you have followed it too much or not, but I'm of the school of thought when I'm doing it that I write the minimum amount of code to make things fail. So basically, just requiring this file makes it fail. So that's where we stop. So the next thing is we're going to do, say, rspec.describe bank, like that, and then we'll run the test again. And we're going to get an uninitialized constant bank, so then we'll jump back into our bank file and write class bank. And now we should be green. So let's actually start working out some of the logic of the bank. So the first thing is, whenever the bank is initialized, somebody needs to sort of own it and have some money in it, presumably. And we're not doing this arbitrarily. When you write a smart contract on the blockchain, there's going to be an owner with initial balance or several owners with initial balances. So we're going to kind of keep that in mind as we're building this out. So it has an owner with an initial balance. And so let's see, I've been writing JavaScript tests, so let me make sure I remember how to do this. Maybe that actually doesn't need parentheses. And let me make sure this runs. I haven't messed up my syntax. Okay, cool. So the first thing we want to do in here is say bank equals bank.new. And we'll give it the name of an owner. Let's actually say like a hash, and we'll say owner, and we'll call this Jim Bob, and then we'll say balance, and we'll say 1 million. Actually, I'm going to do _00, so it's a little easier to read. And then we'll say expect bank dot owner to equal Jim Bob, and we'll expect, actually, you know what, I'm going to comment those out and stick to what I said a minute ago. Writing too much code, so we'll get the wrong number of arguments. So def initialize, and then we'll just say owner adders, and then we'll just grab at. Actually, so let's see if we're passing here. Okay. And we'll expect the owner to be Jim Bob. And we'll say at owner equals owner adders. Nope, that's wrong. And we said owner, not name. And at balance equals owner adders balance. Gosh, I'm getting ahead of myself over and over and over. Let's just make sure this passes. Undefined method owner. Okay, it doesn't, so I need adder reader owner. Okay, and now we're going to set up the balance. So this is a little bit meticulous right now, but this is going to come in incredibly handy once we get a little further down the line. So right now we have an undefined method balance, so I'm just going to set balance here as a method to solve that error. And I got nil when I should have got the balance set by Jim Bob or from the owner adders. So, okay, now we're green again. So the next thing that we need to be able to do is add accounts or set up accounts at this bank. So let's see. So it can create new bank accounts. Something like that. So we're going to write a little bit of code here. So first thing I'm going to do is grab this bank again. And I'm going to say bank.create account. And let's say we're going to give it 2 arguments, or just an argument. Let's give it a username. So I'll just give it my name, and let's run this because this is going to break now. Undefined method create account. So we need to write that method. So the first thing I'm going to do is just write the method literally, and then run the test again. Wrong number of arguments. Let's just say it's a username. Okay, and now we're green. So how do we check that my account exists? So we could say, first of all, maybe we could just check a balance. Check that my balance is not nil, perhaps. You might want to say that, okay, well, we could check that. We could write a method to check if the account exists. And I want to avoid that a little bit because I know that's actually quite problematic on, like, for example, say Ethereum. What you would do on Ethereum is query and see if you have a non-zero balance. And in fact, the whole idea of whether or not an account exists on Ethereum is sort of moot because all accounts exist all the time. You know what, for now, I'm going to keep this simple, and we're just going to check that it has a balance that is not nil because we're writing Ruby and not recreating Ethereum right now. So let's just do that. So let's say expect bank dot balance of Steven to equals 0. Okay, so this is, as much as I can, I want to stick to concepts that you're going to see around the blockchain sphere. So this balance of thing is definitely something you'll see again in other real, actual blockchain projects. But this is going to cause our test to break again because we don't have that method. So we're getting into a little bit of like a nested deal here. So we'll say balance of username. We'll try to speed up a tiny bit without skipping too much. Okay, expected 0 got nil. So there's a few things sort of missing here. So first of all, it might be useful to say in the initialize, we could say at balances equals a hash, and maybe we say at owner dot toSim, and then at balance. And what that's going to do basically is set up a balances hash where it's going to look like, so what this actually will look like is Jim Bob. That's what that will look like in the very beginning in our tests. So what does this mean? So what we can do in here, and I know that I'm kind of skipping around according to TDD stuff like I said I wasn't going to do, but we're trying to not make this take 47 hours. So at balances username equals 0. Okay, so that kind of makes sense. And then here we'll just say at balances username, and run the test, and we're green. So let's jump back over to the test and let's see about a few things. So the bank owner, the bank balance is 1 million. Just wondering if I want to attach that somehow to. No, it's probably important to keep those in their own thing, because like on a Bitcoin and on Ethereum, there's a max number, a total supply of a certain number. And so the idea here is like we're going to give the owner that balance, and there shouldn't ever be more than that. In this particular chain, I mean, you can make different decisions when you build your own blockchain. But in this one, there's going to be 1 million only, or 1 billion, whatever gets passed in. In actual fact, I'm going to make a change, and I need to change it in the test. Let's see here. So let's call this total supply. Yeah, let's call that total supply like that. And then I'm going to check the total supply here. And I know that's going to break some stuff, so I'm just going to run that. But over here, we just need to change balance to total supply. And then there, and there. And now it should be green again. And that's starting to look a little more like the naming conventions I'm used to seeing in smart contracts and stuff. Okay, so what's next? The next thing we need to do is implement the transfer. So it allows, how can I say this? It allows clients to transfer funds to each other. Okay, so the first thing I'm also going to do is set up something at the top where I say before. So now I don't need to. Actually, I'm going to do something even better than that. Let bank and I think that means we don't need to set that bank variable up everywhere. Just to be sure, let's run the tests. Okay, cool. So moving on. So what I want to do here is basically run a function called transfer and essentially be able to send funds from one party to another, and that's pretty straightforward, obviously. So let's say bank.transfer. So we're going to say from Jim Bob to Steven, and then the amount. And let's just say he sends 950. Something that is bugging me a bit is I think I need to downcase everything. I'm going to put this in the test. I'm going to change this to be Jim Bob here, like that. And so I don't get that blown up on me. Expect the Jim Bob guy, Jim Bob. So at owner equals downcase, and then username dot downcase and username dot downcase. I think that's just cleaner. I don't want to have to worry about like syntax or whatever. So let's run this. We're going to get a failure. Undefined method transfer, which we expect at this point. So this is also very similar to something you would see in an Ethereum smart contract. So you would say, so we're going to write a method called transfer from to an amount. Okay, let's check this out. I could have did that with the arguments. So what I need to do now is say expect bank.balance of Jim Bob to equal, what is a million minus 950? So we have 999,050. Is that right? Too many numbers there. 999,050. Okay, and let's run this. And we got nil. Expect bank balance of Jim Bob. Oh, I see. No, I don't. What's happening? Why is Jim Bob's balance nil? Let's check this up here. Let's do expect bank dot balance of Jim Bob to equal this, see what that does. Okay, so we got nil here. So something's going wrong with my case stuff, I believe. At owner equals at owner adders. Now for one of my favorite tricks, acquire pry. Okay, let's just check this. Undefined method to sim. Okay, I should run this actually. And then Jim Bob, nil. Okay, so my total supply isn't coming through correctly somehow. Total supply, bank.new, total supply $1 million. Did I misspell something? Let's look at the owner adders. Oh, okay, I didn't run that yet, so that's my fault. Okay, so balance of, oh, it's because I need to convert it to a symbol. Okay, here we go. Here we go. Quit being a dummy. Control D to get out of all that stuff. Okay. So there you go. So we need to make that a symbol when we bring it in. So in each case, we're going to convert it to a symbol. And let's run these tests again. Okay, now that makes sense. Sorry about that. Okay, so over here, so bank transfer Jim Bob 950, expect balance of Jim Bob to equal that. So the first thing I'm going to do is say if, well actually I'm not going to test any conditionals yet. Let's just fix the transfer logic. So say at balances from minus equals amount, and let's run the tests. Defined. Okay, I have the same problem here. So dot down case dot to sim. That's becoming clear. We need to do something about that. Okay, so let's do this. Let's go ahead and continue with our expectations here. So we're going to expect Steven to have 950. Okay, and Steven is freaking nil. Why is Steven nil? Username downcase to sim. Oh, it's because I need to create the account again here. Because I think a new bank gets created every time I run my tests. Okay, let's try that again. Should be 950 and 0. Yeah, okay. So yeah, this let is running before each test, so there's not a Steven in this test, but there is up here. We'll deal with that later. Right now, let's just deal with the logic here. So the next thing we need to do is add balances to downcase.toSim plus equals amount. Undefined method plus for nil class. Okay, one more time. We'll throw a pry in here. I'm just going to leave that there. Okay, 2 balance of 2 is nil. That's so strange. Add balances. Huh. So I created the account, right? Let's just check right here. Let's quit that. Okay, that's just going to fail out. Why did that fail? Oh, I gotta quit making crazy, stupid mistakes. Here we go. Try to transfer before we actually create the account. Okay, now we're talking. Finally, let's see if this works. Okay, so now I don't have any failures. Let's do this. So it doesn't allow clients to transfer more than they have. Okay, so we're gonna copy this again. Let's just create an account for Sarah. Let's transfer from Jim Bob to Sarah for 9 million. Okay. Expect balance of Jim Bob to equal 1 million. And expect Sarah to have 0. Okay, so right now we're letting people transfer money they don't have, so that's not good. So we're going to say return if balance of from is less than or equal to amount. Run the tests. Wrong number of arguments. Oh, I need to give that parentheses, not square brackets. I have not had enough coffee yet today or something. Okay. And actually, there's a mistake in here too, and I'm going to emphasize it by writing another test. It allows clients to transfer all of their money. So in this case, we're going to create Sarah, transfer $1 million to Sarah. Expect Sarah to be 0 and Jim Bob to be, or Sarah to be 1 million and Jim Bob to be 0. So that's a bug that I just introduced. So what I need to do, so I like whenever there's a bug, I write a test about it so that it doesn't happen again. So we only want to throw it, or not throw an error, but return here. So simply just not execute everything if the balance of the person trying to send it is less than the amount. If it's equal to the amount, it should be fine. Okay. So finally, let's make it so that people can't steal each other's money. So at least in the way that I'm about to show, it doesn't allow negative amounts. So let's do, copy all this again, and we'll say create account, Jeff, transfer from Jim Bob to Jeff. Actually, let's say Jeff is transferring to Jim Bob, and he wants to say -1 million. expect bank account balance of Jim Bob to equal 1 million, and expect Jeff to go to jail. No, I'm just kidding. He should have nothing. Okay, so hit this, and now we get that the balance of Jim Bob, no, the balance of Jeff is a million, right? Actually, let's invert that so we can see that Jeff actually did take all of it, because what that is failing on Jim Bob and saying, no, actually it's 0. Okay, so we expect Jeff to be 0, and we got a million. So what's happening is we can send negative numbers through in the amount right now. So we're going to say return if amount is less than 0. So that will keep that from breaking. Okay, cool. So that's pretty much it for the core bank logic. We've set up all of this in about half an hour. The next step that we're going to work through is setting up client, client systems that can talk to the bank. For the very, very beginning, it's just going to be a simple class that talks to the bank. Then we're actually going to put the bank on an HTTP server and let clients talk to it there, which is where we're going to start running into lots of problems, and we'll build out some cryptographically signed messages for our authentication, things like that. We'll start looking into gossip protocols and how that's going to solve some problems for us. But that's pretty much it for this one. Like I said, I think part 2 will probably also be about half an hour. We'll set up the client library. And I think we may start looking at the cryptographic authentication in the next one. So anyway, stay tuned for that, and I will talk to you next time.